Welcome to 3 Inquisitive Kids. In this video, we will be doing 2 factoring problems. Here's our first problem. We need to factor this polynomial. Let's observe this polynomial. We see that it has 6 terms, but we can break it down into smaller sections and maybe find some similarities from each section. So let's break this polynomial down the middle. Because we see we can factor out an 3x from the first 3 terms to get 3x times x squared plus 2xy plus y squared. And for the second half of our polynomial, let's rearrange the terms a little bit according to the degree of the term. So we start off with y cubed minus 2xy squared minus x squared y. And we can see that we can factor out a negative y from this trinomial. That would leave us with y squared plus 2xy plus x squared. So here is what we are left with. We can see that this trinomial and this trinomial are identical. It's just that we wrote the x squared and the y squared in flipped order. But we could go ahead and factor that out. So we would have x squared plus 2xy plus y squared times 3x minus y. And are we done yet? No, not yet. This first trinomial is a quadratic that can be factored further. This is just equal to x plus y squared. It's the perfect square formula, times 3x minus y. And there we have it. We just factored a 6-term polynomial. Now here's our second problem. We see that we have an x to the 8th power and an x to the 4th power. 8 is exactly 2 times 4. We're used to factoring quadratics and not this high of a power. So we can use another variable, like a, to substitute for x to the 4th. Now when we rewrite this polynomial, all we have to do is factor 4a squared minus 61a plus 225. Well, 61 is the very odd number here because it's prime, and 4 and 225 are both perfect squares, and 61 is not. So if we're trying to use the perfect square formula, 4a squared is equal to 2a times 2a, and 225 is equal to 15 times 15. If it was just 2a plus 15 squared, this expanded would be equal to 4a squared plus 60a plus 225. But of course, since we have a negative sign in the front, let's just make it a minus 15. So when we change that, it's 4a squared minus 60a plus 225. This is awfully close to our original polynomial. So we can just add something to our original polynomial. We can say that our original polynomial is the same thing as 2a minus 15 squared. But we just have to minus an extra a at the end. Now, what was this a again? Well, this a in the back is the same thing as x to the 4th power. As you can see, we have a square subtracting another square. I can rewrite the x to the 4th as x squared squared to help you better see this. We can now use the square difference formula. The square difference formula is 2a minus 15, the first base, plus the second base, times 2a minus 15 minus the second base. And now we can substitute a with x to the 4th power. This gives us 2 times x to the 4th power minus 15 plus x squared times 2 times x to the 4th power minus 15 minus x squared. And each of these is factorable. Now let's say that b is equal to x squared. So then the first polynomial would be 2b squared plus b minus 15. And the second polynomial would be 2b squared minus b minus 15. So how do we factor this? 2b squared is equal to 2b times b, and 15 can just be 3 times negative 5. So when we do their cross multiplying, we see we have a 6b and a minus 5b. So we are left with just b, and this is the exact same as what we have in the middle. So we can factor the polynomial to be 2b minus 5 times b plus 3. And what about our second polynomial? Well, the 2b is still equal to 2b times b, and now the negative 15, we can rewrite it as negative 3 with the b, and the positive 5 with the 2b. So now when we cross multiply, we get a 5b minus a 6b. That is indeed equal to negative b, same as what we have in the middle. So our quadratic factors out to be 2b plus 5 times b minus 3. And now we can substitute x squared for b. 2x squared minus 5 times x squared plus 3. And then 2x squared plus 5 times x squared minus 3. And now we have fully factored out our original polynomial. I hope you learned something from this video, and I'll see you in the next one.